All right, well, we've been looking at graphing exponential functions, and we just recently looked at a decay function where we're raising a value less than 1, greater than 0, less than 1 of which gives us that raised to a certain power, which gives us that decay function feature. So let's see, let's take a look at this. We got a little word problem here. We're going to build an exponential decay function, and then we're going to graph it and make a prediction. So let's see, the average teen can eliminate approximately 12.5% of caffeine from their system per hour. A cup of black tea contains about 68 milligrams of caffeine. Draw a graph to represent the amount of caffeine remaining in the body of an average teen after drinking a cup of black tea. Estimate the amount of caffeine in the body 2 hours after drinking a cup of black tea. Well, let's start here by looking at our basic format that we're going to use, which is y equals a. This is the initial amount. A represents the initial amount, times 1 minus our rate of change raised to the power of t, power of time. In this case, we're talking about where t is equal to hours. Well, let's see. Let's fill in what we know. All right, so we know we got 68 milligrams to start with. So y equals 68. And we know that this is decreasing by 12.5%, which gives us the 1 minus 0.125, and that is what is raised to the value of t. And let's go ahead and just do just a little bit of simplification in here before we go graph. And so we can then graph the function of 68, and of course 68 represents the initial amount of milligrams of caffeine in this T system. And after subtracting the rate at which it is eliminated, the 12.5% put into a decimal, that's the 0.125, we get 68 times 0.875 raised to the value of t. Now on the calculator I'm going to use x just because it's simpler to use, but t is equal to time in hours. All right, well there's our exponential decay function. Let's go graph this thing, and then we'll make a prediction about the amount of milligrams of caffeine in this average teen's system 2 hours later. All right, well, here we are. We're on the calculator, and I first start here at the Windows settings because I'm thinking about exactly what we're going to be graphing. And so I set the X minimum at 0, you'll see here. And I set the X maximum at 10 because that's going to be plenty long enough for us to make this prediction in 2 hours where X equals 2. And then I set the Y minimum at 0 because I don't think we got negative caffeine. We may get down to 0, but I don't think we're going to ever have negative caffeine in our system. And I set the Y maximum to 70 because we're starting off at 68 milligrams. Then it's going to decay and decline. So I put the maximum value at 70. And I went ahead and just did a scale of 7, so every tick mark there will represent 7. So we'll have 10 tick marks on the positive side of the y-axis. So the point being, you want to think about your Windows settings, what you need your Windows settings to be before you actually start graphing the thing. Because you're going to think about it sooner or later. Might as well do it sooner. All right, so let's see. Let's go in here to y equal, and our function, I believe, was 68. Yeah, it was 68. Okay. 68 times 0.875 or 0.875. I'm just going to leave the 0 off. 875 parentheses caret x. I'm using x for t. Okay. Well, let's see what our graph looks like. All right, so there's my exponential decay function. We start off high. We're gradually, well, not even necessarily gradually, we're moving lower over time. So there we've graphed this exponential decay function, the 68 times 0.875 raised to the power of t. What makes it a decay function is we're raising something to a power, and that something, if you will, is less than 1, is 0.875. And I'm going to just go into the table since we're just trying to predict for 2 hours. Let's see when x is equal to 2, what y is. Second graph table. And oh my goodness, I should have set my table setting. Let me go back over here. I'm going to change this. We'll go second table set. I'm going to have it start at -4 just because I'm thinking about what's happening in the future. And I'm going to change this to 1. Okay, that ought to work. Now let's go back to the table. We should have something we can work with. All right, there we go. And I can see here that when x is 2, that would represent 2 hours after the 68 milligrams of caffeine's been ingested into the body, that we should have, based on that rate of decay, 0.875 after 2 hours, we should still have remaining 52.06 milligrams, units of measurement are important, milligrams of caffeine in the system of this average teen after drinking a cup of black tea. Shazam.